So good afternoon everyone and welcome to the SIM lab after your internals. Right, so until now we were dealing with CNC related to the turning operations, and now we need to focus on milling. So one part of your SIM lab is done, so we need to focus on the second part of your SIM laboratory, which deals with CNC mill. So here we will be using CNC mill software similar to that of CNC turn software what we were dealing in the previous classes. So even CNC mill software basically needs to use the G codes, M codes to do various type of milling operations. And here slightly there will be change in the G code and M code with respect to the G codes and M codes what we were dealing previously in CNC turn. So I just wanted to brief out all the concepts related to CNC mill before starting with the milling operation programs. So now you are aware enough that whether it is CNC turn or CNC mill, you will be having a block which consists of the G codes and then the word which will represent the coordinates of X and Y, and also the feed rate with which you have to assign to see the operation is done. Similarly, the same funda will match here in case of CNC mill also. So basically, if they ask you CNC mill, it is a special purpose CNC part program, right? What we write to verify how the milling operation is done with respect to the machining center. So here also we use the blocks of words, and words consist of coordinate system. So this is a basic every line, the sequence what we follow in case of milling operation as well. So basically, even in CNC mill, you will be having the G codes and the M codes what we follow. You know the purpose of G codes and M codes. And similarly here, in case of milling operation, most commonly we use different type of tools to correspond different type of motions. It could be rapid motion, feed motion, a circular, in order to assign the dwell time, and also to use the can cycle codes. Here, in case of CNC mill, we will be having the sub-programs. We can call the programs when we need to perform different can cycle operations. Right? So we have different codes for can cycle operations also. We'll be dealing one by one. Apart from that, the miscellaneous codes, as usual, we use it for making the spindle on or off, either to change the tool and to make the coolant on or off. So the purpose is the same, only thing the few terms gets changed when we come for CNC mill. So apart from that, again these all will stand the same. So N we refer for the block number, so G are the preparatory codes, M is a miscellaneous function, so X will yield you the coordinates for X axis, similarly Y for Y axis coordinate system, for Z axis. And apart from that, you have the term here I, J and K, what you didn't had in case of turning, right? So here I will refer for the X-axis location from the center of the arc. And similarly J will refer the Y-axis location from the center of the arc, or you can call it as arc center. And similarly K will refer the Z-axis location at the arc center. Okay, so this is about I, J and K. Apart from that, S stands for the spindle speed, F will stand for the feed rate as usual, and T is for the tool number, what we follow. So this is about the basic key elements that even you are thorough enough. Only the extra part what you have to be aware enough is related to I, J and K, which ascertains you the center of the corresponding arc what we are selecting. Okay, so then the main important thing is the coordinate system. In case of CNC turn, we had only two axes. Which were the two axes what we used in CNC turn? Anyone can let me know? You had three coordinates or two coordinates in case of CNC turn? Hello, you should answer. Which were the two coordinates we used? I won't move further if you don't answer. We have done all the programs related to turning operation. You should be able to tell me which were the two coordinates we used. Answer me. You had 3 axes or only 2? If it is 2, which were the 2 axes? Gautam Krishna, you're there? Anil Kumar?
Yes, ma'am.
Yeah, which were the coordinates we used in case of turning operation?
X and Z.
Ma'am, X and Z.
Yes. Why it took so much of time for you people to answer? You should be quick and respond when the question has been asked to you all. That shows that you're listening and you are interactive. It should not be a one way. You should speak on.
Okay.
Yeah. So we used only 2 coordinates in case of turning, which was the z-axis as well as the x-axis. But here in the CNC mill, we use basically the 3 coordinate system. So you'll be having both all the 3 coordinates x, y, and z. So you can see the thumb rule with respect to the direction, which will be the positive. So this will be positive x, positive y, and positive z direction. So we follow the directions defined by the right hand thumb rule. Everyone are aware enough with respect to the right hand thumb rule. The same concept we do follow, right? So if it is an vertical axis milling machine, so then you can see Z here, okay, X here, and this is the direction of Y. So positive X and negative X, positive Y if it moves towards, if it moves away from your end, and if it is towards you, the moment, then it is negative. And similarly, this is the direction for positive Z, and this is the direction for negative Z. So that this is the direction for the vertical milling machine. So here the coordinate system, we follow the thumb rule for right hand thumb rule as for the sign convention. And always remember the Z axis will be along the direction of the spindle. So this is the one thing you have to keep in mind. And next option is with respect to the thumb. So the thumb will provide you the positive X direction, while the index finger points, this is our index finger and this is our thumb. So the index finger will show you the Y direction. So this is positive Y, and the thumb will show you the positive X direction, right? And Z will be the direction in which the spindle axis is there. So this is your positive Z, and this is your positive X, and this is your positive Y direction, what we usually follow in case of CNC mill. So the sign convention is based on the right hand thumb rule. And suppose if you have, if you need to know the sign convention for the rotary axis, so this is a thumb rule what we follow. So this will be the positive direction for the clockwise rotation, right? So the rotary axis here for X, Y, and Z are called to be as A, B, and C. So this is the axis direction for an horizontal milling machine. So you can observe, so this is the direction of rotation in the clockwise direction will be considered as positive. So this is positive X and this is negative X, and this is positive Z and this is negative Z, and upright is positive Y and below is negative Y. So this is the sign convention we follow for the horizontal milling machine. Apart from that, the rotation, the rotary axis will be positive for the direction which is being shown over here. Okay, so this is about the convention what we follow for the rotary axis. So this is a basic coordinate system what we do follow in CNC mill. So then comes as usual the different types of codes to analyze different motions or the movement of the tool. So G00, you know that it is for rapid traverse. Previously in CNC turn, we had only 2 coordinates, X and Y. But here you have to mention X, Y, and Z. So it will locate you the coordinates for the destination point where you have to want to place the tool. We usually use the rapid traverse to bring the tool nearer to the blank. So if you want to bring the tool nearer to the blank, then you should specify which is the value of x, y, and z. Suppose your reference point is here. So then you will locate the direction of x, y, and z, in which direction you are ascertaining. So you have to write G00, then provide the coordinates for x, y, and z, so that the tool will come to the nearer to the place of the blank. The same function, only thing you will be adding on the z coordinate to it in case of rapid traverse. And then comes the linear interpolation. We have studied linear and circular interpolation in case of CNC turn. Similarly, here you do have the linear interpolation, right? So here also we do use G01 as for the linear interpolation, but there you had x and y, but here we are adding the coordinate z to it. Okay, along with that you have to provide the feed rate, which has to be ascertained, so that the tool will move in a linear direction with respect to the coordinates what you will be assigning. Okay, so we have seen an example over here also. Like if this is a given blank, right, if you want to do a linear interpolation, so this is our reference here, which has been taken 0, 0. So then if you want to move to this location, so what is this distance? Is exactly 145.5. So you have to give the coordinate for the value of x from this reference to 145.5. And similarly, to move to this location, you need the value of y from here to here. It is exactly 50. So you'll be giving a value of 50. Along with that of the feed rate value, you have to ascertain to move from point P1 to P2. Okay, so this is just a simple example how the tool can traverse in a linear interpolation. So everything depends from the coordinate system where you are ascertaining the values. So this is just an example for G01. Similarly, you know that G02 and G03 is mainly for circular interpolation. So it could be either the clockwise or it could be the counterclockwise. If it is clockwise, we use G02. If it is counterclockwise, you will use G03, right? So this you are keenly aware enough, right? But when you try to write the G code with respect to the syntax, what is the format being followed? You will write depending upon this interpolation either G02 or G03. After that, you should provide the x coordinate, the y coordinate, what is the radius of the arc, and what is the feed rate you are going to give. So you will be having a start point and an end point. So if you want to draw an arc, you need to show the center and then you need to ascertain the value of the radius. Then only you can show what is the radius of the arc which is moving from start point to that of the end point along with the feed rate. So this will be the syntax what we follow in general. Either it is clockwise interpolation or anti-clockwise circular interpolation. So based on that, only either G02 or G03 gets changed. The remaining thing will remain the same. So this is about the circular interpolation what you have to follow. Okay. So this was the thing what we discussed for arc center programming. So this is a center, so you will make an arc from start point to end point. So when you make an arc from start point to end point, you will need to show the coordinates of I and j. What I told you, this will be the extra part what you will be adding on in CNC mill, which was not there in CNC turn, right? So this is for arc radius programming. So you have done it. And similarly, you have arc center programming. If you need arc center programming where I and j term is needed, then you should follow this syntax. So this is only for arc radius programming where I and j will not come into picture. If I and j is needed, you should go for this format of the circular interpolation, which will be having I, j along with the feed rate with respect to the coordinates of x and y. So if you need to make an arc here from the start point to the end point, you'll be having the coordinate values. So you will write down what is x and what is y. Along with that, you should tell what is I and what is j. So if you want to draw the arc, so from the end point, I will be the x coordinate of the center right? So this from here to this center. So this distance will be our height. And again, J will be the y coordinate from the center to this position through which the arc is cutted. So you need to know what is the value of I and what is the value of J. So these are the two words what you have to write down, and you have to be careful with respect to the sign convention also. So this is related to the I and J term, which will come into picture in circular interpolation. The same thing, and just a small example has been shown over here, right? So suppose if you want to do an arc radius programming from here till here, so one will be the start point and end point, and again start point and end point. So if you're using the arc center programming, so then you have to ascertain the value of x. Okay, so this is a reference point. So from here, x value, you will be providing it as 120. So where you need exactly the position. So this is 140 and this is plus 50. So you have to see exactly where 120 lies. And if you need, this is a start position. Okay, so here the y-axis will be exactly 60. Okay, so this is the position of y, and x is 120 for the first point here. So first point and the second point. And later you need to give the value of I, and you need to give the value of J. So both these values you should identify from this reference point and give. So this you will come to know clearly when you solve the problem. So now I will just explain you the formats and the syntax which is needed for you to understand the G codes and M codes. Apart from that, in case of milling, because we do the peg drill, the compensation of the tool is very much essential. So this is called as cutter radius compensation. So why and compensation part is essential, right? So when you use any tool to move to a position, so you're actually what you're doing is you're ascertaining the axis of the tool to move from one position to another. But it again depends upon what is the compensation you need to give so that it will make the contour as requirement. So it can move in this way, move in the x direction, again y, x, y, x, y, x, y within the given blank to make the contour. So to make the tool in proper movement, it has to be compensated with some value so that it makes the contour easily without causing any harm to the periphery. And as a result, cutter radius compensation is essential. So in order to provide the compensation, we have three commands here. Basically, one is G41, G42, and G40. So G41 is used if you need to make any compensation for the cutting tool with respect to the radius in the left direction. If you want to do the compensation for the cutter radius of the tool in right direction, you need to use G42. And if you want to cancel the compensation could be given either in left or right. But irrespective of whether it is left or right, if you want to cancel it, you have to use the code G40. So this is the thing what you have to understand. Okay, so the format here, it has been changed. Just a second. Yeah. So now if you want to use G41, means you're providing the cutter radius compensation towards the left. For that, you will be using G00, yeah, slash G01. First, you will bring the tool nearer to the blank, and then you provide a linear interpolation. Once you give the linear interpolation, you provide the compensation for the cutter radius, right, towards the left direction. Then the D will stands for the coordinates value what you assign in X and Y. In this case, the compensation is given towards your left. If you use G42 instead of G41, then you will provide the compensation in the right direction. And if you want to cancel the compensation, then you directly type it as G40 instead of 42, yeah, 41, and this will cancel the compensation. So usually we provide the compensation before the tool moves to form the required contour. So it comes in this way, moves, come, and move with respect to the compensation you're providing either towards the left or towards the right. So this is just an example how the cutter radius compensation happens. So suppose if you're taking G41, so G41 is for compensation towards the left. So the cutter radius compensation towards the left. So you can see it is towards your left, which provides the compensation for the cutter radius. And similarly here, G42. So if you need G42, this is a compensation given towards your right. So here the cutter radius will be having a compensation in your right direction. Okay, so this is the thing what you have to keep in mind. G42 is for compensation at right and G41 is for compensation at left. And if you want to type G40, if you type G40, then the compensation will be off. So this compensation will really help to get the required contours in the given blank as per the requirement. Okay, so this is about the cutter radius compensation. This is very much essential to mill a part along its contour direction. For that purpose, so that the periphery of the tool will move along the contour without causing any harm. And this contour will offset the direction either towards the left or towards the right. So this is the meaning why CRC is needed, and you can select either G41 or G42 based on your requirement. And this compensation, what we were speaking about with respect to cutter radius, is very much essential because we will be using different tools to perform different operation. Every tool will be having some specific length here. So we cannot keep our coordinate system adjusted to this length of the tool and then you see what is this distance and give the coordinate system. It will be very difficult. So that the value will be assigned in such a way that this length protocol compensation will be taken care automatically by the software. Because tool 1 might be having this length of 80. So when it comes for T2, it could be having 160. Again, the tool 3 might be having a length of 100 here and again 200. So this much amount of variations we cannot adjust in the coordinates what we do type on. So coordinates what we give is only with respect to the movement of the tool to get the required path what we need in the blank. Apart from that, this compensation of the length of the tool will be a difficult task if that is not been compensated. And hence this tool length compensation is very much essential, right? For that, suppose the same thing has been explained. This picture shows the tool length compensation of different tools. So it could be like Z80, Z160, Z100, yeah, Z200 for different tools, which is varying from T1 to T4. So these tools are named from T1, T2, T3, and T4. And these are compensation lengths of Z80, Z160, Z100, and Z200. So these values have to be compensated. Why? Because when you use a tool for a continuous period of time, it can worn out. Right? So if the tool gets worn out, you have to remove the tool and change periodically. And every time the coordinate system has to be again rewritten or the whole program has to be changed. So to overcome the toning of the tool, to eliminate these type of problems, we usually go for compensation of the length. Okay, so here in CNC mill, it has been developed in such a way that the program will be written only for the required diagram what you want on the blank. So we will write the program with respect to the path what the sketch has to move on to get the required design. So we will basically write the coordinates only for the path which has to be traveled. But we won't consider the length of the tool what we are using. For different operation, we use different length of the tool. It will not be the same for all, right? But we cannot focus to write the coordinates even for the length of the tool. So in order to eliminate the factor of the length of the length of the tool has to be compensated. In this way, in the software, it is automatically established in such a way that it makes a compensation for the length of the tool. So what they do here basically is all the lengths of the tool are entered in the controller's memory. So what does this controller's memory do? So this controller memory will do the job of adjusting the tool length automatically to the blank. For that purpose, you will get a rapid motion with respect to the coordinate without considering the length of the tool. We won't write anything for the compensation, but that will be taken care by the software which has a controller's memory. So that controller memory will adjust the tool length with respect to the blank dimension and the coordinates what we are ascertaining. So this is the need for tool compensation. Or else every time for different tool we are selecting for different operation, we need to provide the values in the coordinate system to overcome this tool length also. So that will be a little bit complicated, and hence this has been overcome with the help of controller's memory. So that is what I just wanted to tell you. Hope it is clear until here. Any doubts associated with this? Hello, are you people there? I need a response. Are you people there? Is it clear?
Yes, ma'am.
Yes, ma'am.
Then why should I speak so much louder? You people can't answer me once if it is asked. Sometimes I feel whether you people are there or you
Oh,
went to
ma'am, we
sleep.
hear, ma'am. We're listening, ma'am. We can hear you, ma'am.
Okay. So this is the format what we follow basically, right? So I hope I told you this related to G43. So G0, yeah, G01 will be assigned with G43, and this is the offset value of H. And just a second, there is some emergency. 2 seconds, I'll be back. Yeah, I'm back. There was a small circular what I was supposed to sign. So, okay. So we were speaking about the format for our tool compensation. So G43 will always provide the compensation towards the length of the tool, right? And H here will be the offset number. So this is the compensation of the tool, what we are ascertaining, and H will provide the offset of the tool number. And this offset number, what has been mentioned over here, will be stored in the memory, the controller's memory, and that controller memory will help in safeguarding the offset of that tool length with respect to the coordinate what we are writing. So this G43 could be initiated or cancelled by writing either G00 or G01. You can either go with G01, G43, or you can go with G00 with respect to G43. Both the thing is feasible as per the format. And there is a sample program. I'll go to this later after going through all the terminologies. So this is just the compensation part. So what we have studied until now is the basic coordinate system, G01, the linear interpolation, the circular interpolation, why the compensation is needed, and which are the type of compensation we do have, what is the necessity of the compensation, and how the format looks like. And then here also we do use the CAN cycle. So what is the use of CAN cycle? If you don't use the CAN cycle, you have to write a separate programs for each operation. But if you go on with a CAN cycle, you can use you can call different sub-programs within the main program and complete all the operations within the given main program. And hence this CAN cycle will help in performing many operations together by using a set of sequence of tools. So this is the main application of using a CAN cycle. So with the help of a CAN cycle, it helps in executing many operations with the help of using different sequence of tools. So this is basically why an CAN cycle is being used. So even the CAN cycle consists of a block with the data, what is being needed to perform the operation. And finally, you need to approach an exact position. You need to give the value of X, Y, and Z. Apart from that, you need to ascertain what is the final depth value is being needed. So once this data is ready, you can make the program done. So once the program is done, you can execute and check whether the position of the tool with respect to X and Y is moving properly or not. If any repetition is needed, you can re-repeat, or if it is going everything properly, there is no need to repeat the cycle at each and every position. Once the thing is done, the cycle is perfect, so then you can cancel the command and go back to the main program. You will write a main program. In between, suddenly you need one operation, so you call a sub-program. For the sub-program, we use a CAN cycle. Suppose you want to do a reaming operation. You call a sub-program, you write the syntax for the reaming operation and which G codes are needed. Once that reaming operation is done, you will cancel that particular reaming cycle. And then again, you will call for the main program. So it is like completion of small operation within a main program, which is nothing but the sub-program interruptions. So this is done basically in the CAN cycle. So axis convention, I've told you already, you have X, Y, and Z axis. So there is nothing much more in it again. And coming to the CAN cycles, here also similar to the turning, we use the Fanuc machine only in CNC mill as well. So here, as I told you, the CAN cycle, we have different CAN cycles over here, right from G81 to G80. Okay, so here G81 is mainly used to perform the drilling operation. G82 is used for doing the counter boring operation. You have done all this operation using your lathe machines. Similarly, now it is being performed virtually by using the software CNC mill. So to perform these operations virtually, you need some preparatory codes, which are nothing but your G codes. So we usually use G81 to do drilling operation, G82 to do counter boring, G73 we use for doing peck drilling, G83 we use for doing deep drilling. And if you want to do the finishing for the counter boring operation, then you go with G76. And if the tapping operation is needed, you need to go for G84. And if reaming operation is needed, you need to go for G85. And similarly, back boring operation, if it is needed, you have to go for G87. And for the completion of the CAN cycle, you go with G80. So these are the G codes which are already well established to perform different CAN cycle. Means you will be calling these CAN cycles within the main program. So this will be the sub-programs, what you call, you perform the drilling operation and again you close that program. And again you'll come back to the main program. So these are nothing but the CAN cycles, what you should be thorough enough in case of milling operations. Okay, so in that case, this is the first one what you have to understand. So this is our drilling cycle. Okay, so for drilling cycle here afterwards, you should remember always it is represented by G81. So if you see here the diagram, so this is the tool tip what you have, and this is the entire tool tip depth. But the hole will not be done for this distance. It is only done from this point to this, because this is the tip of the tool, the nose radius of the tool. So this will not be helping you to make the hole. The hole depth is ascertained only by this length. So hole depth is called this distance, and the entire tool tip distance is shown by this distance. So the format for G81 here is nothing but you have to write G81, then you have to show the X coordinate, right? And then it is Y, and then you have to show the Z. After that, you will be having a value called initial safe position. What is the initial safe position? So that value will be ascertained by the letter R. And finally, you need to give the feed rate. So that will be given by the letter F. So here you should see how the travel, how the rapid motion, how the motion of the tool takes place in performing the drilling operation. So the red one indicate the rapid movement, right? So by using the rapid travels, you bring the tool nearer to the blank, and this will be the rapid motion which happens. And then you give the feed to perform the drilling operation. So when you give the feed, then the drill bit will move in and perform the required drilling operation, right? And again, the rapid traverse comes back. How you need to remove the tool safely, right, from the given blank. So again, the tool will move in the upward direction. So this is rapid to safe height above the hole. You should be very careful in giving the initial safe position, because initially the tool will be away from the blank. Then you will, by using the rapid traverse, you bring the tool nearer to the blank surface where the drilling operation has to be done. So once you have fixed the coordinate of x and y, then you provide the hole depth. Hole depth is provided by the z coordinate system. So this will be your x, this will be your y, and this will be your z direction. So I'll give the value with respect to the z. So that will provide you the hole depth. So once you have provided the hole depth, the drilling operation is performed. Direction in very safe condition, so that it should not damage either the tool or the blank. For that, you should ascertain the value of R, which is the initial safe position. Forward direction safely above the hole, and then it goes to the home position. So this moment is very much in the hole, and then it goes to the home position. So this moment is very much in need, which you have to understand and be careful. If you go wrong in giving the initial safe, yeah, hello.
Now, what is ascertain, ma'am?
What ascertain? Can you just tell
No,
me
you were
the
saying ascertain, no, ma'am. What do you have to ascertain? What do you mean by ascertain, ma'am?
No, see here, what I wanted to tell you is, so this is a drilling cycle, right? You provide the values of x and z, and you provide the depth of the hole. So this drill will come in and do the drilling operation. Once it is done, I told you that you should ascertain such that it will be very careful. You should be very careful in removing the tool outside the blank, because this tool,
what is that ascertain word?
if you are getting complicated with ascertain, you just leave. You just, what I wanted to tell you is remove the tool. Just
remove
a
the
second.
tool. Okay, fine. Sorry, ma'am.
Remove the tool safely so that it won't make any damage to the surface. For that, it should be moved safely in the upward direction. So if you want to make the tool move safely in the upward direction, you should provide an initial safe position for the tool so that it goes, so that it moves away from the blank. After it moves away from the blank, then you can send to the home position and change the tool. I mean to say that you ascertain that the tool is removed. You make sure the tool is removed safely from the hole without causing any damage to the blank or to the hole which has been formed. That was my meaning. That's it.
Understood.
Hope it is.
Yes.
Yeah. Thank you. So next operation is counter boring cycle. So in counter boring cycle, we use G82. So previously, if from here after, if it is written as G81, you should remember that it is a drilling cycle. So these are the protocols what you have to use in case of drilling cycle. So once this is done, next is our counter boring cycle. So for counter boring, we use the code G82. Okay, so here it is the hole depth, what you can see, which could be formed by using counter boring. So usually we use the boring cycle to enhance the the drilling hole which has been performed. So if you want to do the counter boring, we go with G82. So this is the hole depth what we can use in enhancing the hole which is in existence already. So the format what we use here is as shown. So it will be G82. Everywhere you should be careful to provide the value of Z also, because we are doing milling operation. You have to give the depth, the hole depth which has been needed, not only the position. Along with that, you need to give the hole depth. So the position of the coordinate will be ascertained, will be provided by X and Y, and Z will be providing you the hole depth. So you will write X, Y, and Z. So after this, you need to again give the value of R, which is initial safe position. So once the boring operation is done, this tool has to be removed safely without making any damage to the boring which has been done, and neither to cause any damage to the surface of the blank. So this is a format what we need to follow. So if it is G82, then it is nothing but the counter boring cycle. What we have to do. Apart from that, there is one more operation, what we call as peck drilling operation. So in peck drilling operation, you can see three versions over here. So if this is the tool what we are using, so before going into it, the peck drilling cycle will be represented by G73. Okay, so whenever you want to do the peck drilling operation, we need to call the preparatory code, which is G73. So if this is the tool which is being used to do the peck drilling operation, you will be having the peck depth and the total tool tip depth over here. Apart from that, the whole depth which could be performed by using peck drilling tool is the distance as it has been showed over here. So this is the tip, the tool tip with particular nose radius. Okay, so here you will be having different traverse of the motion related to the tool. So you will be having the rapid motion as well as the feed motion. So the first one is the rapid motion. So you will bring the tool towards the blank. So this is again a rapid motion what you provide for the safe movement of the tool above the hole. So when you bring the tool, you should see that the tool is exactly on the position where the hole has to be drilled out. It is not like partially it is away from the position where the hole has to be performed. You should see that the tool is safely into its location where the hole has to be drilled. So you have to provide a very safe movement of the tool such that it will be ready to get the required drilled hole. So this is the first motion. And then you have to provide the feed rate to get the peck depth, right? So it is not within single shot the entire metal will be extracted. You have to give the peck depth distance. So in one peck, what is the amount of material which has been removed, right? So what is the feed you are providing to get the required amount to get the required amount of material to be removed. So you have to give the feed rate with respect to the peck depth distance which has been required. So this, when you go for the tool library, you can check what is the peck depth for that particular drilling tool what we are using, and what is the entire length, and what could be the possible maximum hole what you can drill with respect to this particular drilling tool. Okay, and apart from that, the rapid retract will be only of around 0.5 mm. So this is first the rapid movement of the tool safely where it has to be doing the drilling operation. And then when you provide the depth, the tool will get inside the given blank to do the drilling operation based on the peck depth. First depth of peck, second depth of peck. Okay, so that the entire hole will be drilled out. So this will be the direction in which the motion will be there with respect to the feed what you will be giving. So this is called as the feed movement, feed motion. So after this, next is the rapid retract by 0.5 mm. So again, this is a rapid motion. You are lifting the tool slightly based on the retract what you are giving. So it is of 0.5 mm. So after this, you will repeat this step of peck depth until the tool touches the distance where the drill has to be completed. So this again is based on the feed movement. So based on the feed you are giving, so this process continues until this entire distance is been drilled out. Okay, so first peck, second peck will help you in completing the required depth of the hole which has been needed. So the second time, this is a feed motion what you are giving. So once this feed motion is done, again you have to give the rapid retract of 0.5 mm. So that will show you the rapid motion which is shown in the red color. And similarly, this process continues until the required drilling of the hole has been completed. And finally, the tool will be safely removed up away from the blank, and then it will be reaching its home position. So these are the motions of the tool which takes place with respect to rapid motion and the feed motion when you provide the coordinate value with respect to the retract value as well as the feed rate. So with respect to these phenomena which has to be performed, it has a specific format. So it is given as G73. It will be followed with X coordinate, Y and Z value. So Z value here also it provides the depth of the hole which has to be drilled. Apart from that, you have to give the value, the initial safe position where the tool could be placed nearer to the blank where the hole has to be drilled out. It should not touch the blank. It should not go inside the blank, and it should be nearer to the blank where the drilling operation has to be done. So that is nothing but the initial safe position. After that, you need to know what is the depth you have to give for each peck. So this is a peck depth value exactly. So this is the maximum distance it can go with an depth of cut for any type of hole to be drilled. So based on that, you should provide the depth for the each peck. And what is the feed rate you are providing? So this will give you the format for the entire drilling operation with respect to peck. So if we need to do a peck drilling cycle, we have to always refer for G73, and this is the format what we have to follow. So this is about our peck drilling cycle. And one more you have related to the drilling again. It is deep drilling. If you want a deep drilling, okay, so which is the code we use? We have to use G83. Okay, so in this we can see that and deep drilling of the hole could be observed. So this is again the entire tool tip depth, and this is the peck depth of the given tool, and this is the whole depth what the tool can perform to get the required deep drilling. And here also it has its own rapid and the feed motion as described over here. And apart from that, similar to that of G73, you have the syntax. So it is G83 followed with X coordinate, Y coordinate, the depth of the hole, what is the initial safe position value, right? And you have to give the depth for each peck followed by the feed rate. So it is the same thing what we follow for G73 also. Only thing is slight variation in our rapid and the feed movement. So first one is you provide a safe position for the tool to be placed across the position where the hole has to be performed, but it will not go inside the blank, it will be above the hole nearer to the blank. So it provides you the rapid motion. Rapid motion is represented by red color. And then you will provide the feed value. So once you provide the feed, the tool will go inside the blank and this will provide the feed motion. So once the feed motion is given, you provide the initial safe position so that it helps the tool to bring back above the given blank. And later again you will bring the tool nearer, you will retract some material, you will provide the retract value, so it will move up, and again you provide the rapid motion, you will bring the tool nearer to the blank, and then you provide the feed, so it will provide the feed value. But here what you have to understand is after the rapid you will provide a dwell time. Dwell time is nothing but the soaking time or the lagging time which will be idle for some particular period, because you are going for deep drilling. So when you perform deep drilling, some chips can come out. So in order to not perform any operation during the chips coming out, you provide some dwell time after each operation. So this is not needed in case of normal peck drilling. But if you are going for a deep drilling cycle, then there are chance for the chips to come out. So you cannot make the tool continuously move in and out and do the deep drilling. You should wait for some period of time. And hence you will assign some dwell time so that the chips are thrown out. Okay, so once the dwell time is over, then again you will send the rapid motion, so that after 3 you can see there is a dwell time for the fourth one, there is no direction. It is just the dwell time where the tool will not be performing any operation. Some period is kept lagging so that the chips, if anything is there, will be moved out. So after the dwell time, then again you provide the safe rapid traverse movement of the tool nearer to the hole. So once the tool is coming nearer to the blank surface where the hole has to be drilled, then again you provide the feed motion, so the drilling operation will be done. So after that, again you provide a dwell time. So you'll repeat this process until the required drilling operation has been completed. So this is the difference between the peck drilling and the deep drilling cycle. In deep drilling cycle, you need to provide some idle time, which is the dwell time, to remove the chips. Apart from that, the rapid motion and the feed motion were exactly similar to what we explained in case of regular peck drilling operation. So after that, I hope it is clear. Any doubts? Are you people there?
Yes, ma'am.
Okay, so next is finishing boring cycle. So if you need to do an finishing part for the boring which is done previously, so then we have to go for G76. Okay, so this will follow and again a format here. So before going to this, you can see that this is the maximum hole depth which could be finished for the existing boring. So the regular drilling will be done. If you use an finishing boring cycle, it helps to extend the boring cycle with a boring part with an finishing across the edges. So usually it will provide a lateral shift before retracting any material. So this is the direction in which the lateral shift will be given. And this is the maximum hole depth of the tool what we are using for boring cycle. Okay, so basically this is the format we follow. It is G76 followed by X, Y and Z. Okay, so your X and Y will provide the position of the hole in which the boring has to be finished, and R will provide you the hole depth again. Z will provide the hole depth again, and R will be the initial safe position so that you can remove the tool safely above the blank and you can keep it nearer to the blank. Okay, so then again you have to provide the value here. What is the shift amount at the bottom of the hole is needed? Just a second, there is an yeah, sorry for the disturbance. So here what we were discussing is about the format what we have to follow. All the things are same. X and Y will provide you the hole position. Z will provide the depth of the hole which is needed. R also you know, which helps in lifting the tool above with an initial safe position nearer to the blank. But Q is the extra part what you have to understand. It is the shift what you need in enhancing the bore which is already there for the finishing purpose. So here you should be very careful in giving the amount which is needed in extension across the bottom of the hole. So after that, even here you have to give the dwell time across the bottom of the hole which has been needed, right? So P will stand for the dwell time. Apart from that, the feed rate is always there, so F will provide the feed rate. So this is the small change we observe here. One is the shift amount and the dwell time what you have to add in the syntax. So if you add these two parts, then the syntax for G76 will be ready, which has been used for finishing boring cycle. And again the tool path will be as usual. It will be safely brought nearer to the blank where the whole operation has to be performed. So this will be nothing but our rapid motion due to the rapid traverse of the tool. And then you will provide the hole depth by which the feed motion will come into picture for doing the finishing cycle of the boring operation. And after that, based on the initial safe position value given, so the tool will be removed safely above the blank once the required boring operation is been completed. So this will be the syntax what we use for G76. After that, the very commonly used always is our tapping cycle. So tapping cycle basically we do use to perform the threading. It could be like right hand threading, yeah, left hand threading. Okay, so if you want to do an right hand threading, so then you have to go for using G code as G84. So this will be the structure of the tool, how it looks like. Okay, so this cycle always follows by default and right hand type of thread. By default, if you type G84, it is mentioned only for right hand thread. It won't do any left handed thread. Okay, so you should be careful to select which type of threading is needed, either right handed thread or left handed. So it moves from right towards the operation. Okay, so here again, this is the maximum hold depth you can get for the threading. And you have the two parts again here. One is the rapid motion, another one is the feed motion. So what happens basically, the first you will keep the tool nearer to the blank, right? So it will be the rapid movement of the tool which is nearer to the blank where the hole has to be, where the threading has to be done across a particular hole. So then second is it will start rotating in counterclockwise direction. The tool what you have provided will move in the counterclockwise direction. It starts rotating and it goes into the hole where the thread cutting has to be done. Okay, so after that, what it happens is it will reach. So this is the feed movement. So once it rotates and comes down, it has reached the hole until the tip where the thread cutting operation has to be done. So this is the direction in the feed motion which is done. So once it is reached here, the spindle will be off. So once it has reached the whole tip, the spindle will be off, mean to say that the tool which was moving in the clockwise direction will now stop. You will not be having any rotation aspect. So once it is stopped, you will be having a dwell time there. So some period will be idle without any rotation and without any lifting of the tool above. So that is nothing but the dwell time. So after that, what happens is after the dwell time, the tool starts rotating in opposite direction, in counterclockwise direction. Okay, so then after the counterclockwise direction completed, what happens is you will provide the safe position for the tool to move outside the blank. So with that, it will move away from the blank. So for that, it is the value what you have to give, the feed value with a safe position above the hole. It will move above the hole. So this is the operation what happens. First it comes near the blank, right? And then it starts rotating in clockwise direction. It touches the hole and it results in the formation of the thread cutting. Once it has reached the tip of the hole, the spindle will stop. It will be idle for some period of time. Then again it moves in the opposite direction, in the counterclockwise direction. Then the tool will be safely removed above the blank and it will be sent to its tool position or the home position. So this is the operation which happens in right hand thread. So the format given here is as follows. So it will be using G84. X and Y will provide you the hole position. Z will provide you the depth of the hole. And R will provide you the initial safe position to place the tool nearer to the blank where the thread cutting operation has to be done in the position of the drilled hole. Okay. So then you have to provide the dwell time here. What is the dwell time? It will be idle after rotating in clockwise direction. And then finally you have to provide the feed rate. So these are the values what you have to follow as a part of syntax for the tapping cycle, which is nothing but G84. And what else we have? We have tapping cycle, okay, in the left hand. So if you want to have the tappings or the threading in the left-handed cycle, so then you have to use G74. So this G74 will basically give you the left-handed thread, right? So here basically this is a maximum hole depth you can get by using the this one left-handed thread G74, and this is the movement of the tool. So what happens first, initially the tool will be brought nearer to the blank very safely. It will not touch the blank, it will be above the hole, and then it will start rotating in the counterclockwise direction. First, in case of right hand, it moves in clockwise, but whereas in case of left-handed thread, the tool start moving in the counterclockwise direction. After moving in counterclockwise direction, it comes to the tip of the hole. So when it touches the tip of the hole, the spindle of the tool will stop. So it will not rotate. It will be held for some period of time. A dwell time you have to provide. So once a dwell time is completed, then the tool again start moving in clockwise direction, and it slightly safely it gets removed away from the blank without causing any damage to the blank or to the thread which has been formed. So these are the motion which happens. Okay, initial rapid movement, then it moves in counterclockwise direction. Right after the thread which has been formed, it will stop for a certain period of time, then it moves in clockwise direction and it is safely brought above the blank with the required thread which has been formed. So this is the motion which usually takes place in case of tapping. So after this, the basic format is the same. There is no much change here. Only thing is G74, it will be followed by X and Y position. Z will provide the hole depth again. R will be the initial safe position, what you have to give to move the tool above the blank safely. Right, P will be the dwell time, what you give when the tool touches the bottom of the hole, and F is the feed rate in actual, what we have to give. So these are the different rapid motions which come across. So if you understand the movement of the tool, how it moves, as per that, it will be very easy for you to provide the values as per the format. So this is a tapping operation which will be performed in left hand type of thread. So what else we are left out? We are left out with reaming cycle. So if you want to do an reaming operation using CNC mill, we use the code G85. So this G85 will come with this format. So this is the maximum hole depth what we can do. So initially what we do is we'll bring the tool nearer to the blank above the hole, not touching the blank. Okay, so that is a safe position value R what we have to give. So the tool will move nearer to the blank. So this will be the position basically. Then you provide the feed. So when you provide the feed, the tool will come to the bottom of the hole where the drilling has to be completed. Right, so this is the feed motion which will come down until the bottom of the tool. So once this has been reached, then you have to again provide a safe feed position such that the tool could be removed safely above without causing any damage to the hole across the surface of the blank also. So this is the motion what we get usually in case of even in reaming cycle. Now it has three types of motion: the rapid movement and the feed motion. Right, so after that you should be careful with respect to the format. In the format basically deals with G85. It will be followed with the coordinate position of the hole, which is X and Y. Then the depth of the hole will be given by Z, whereas R will provide the initial safe position. Okay, so then again the feed rate. So if you assign this amount of values, so then it will be helpful for you to get the required reaming operation done in the given blank. So this is about the reaming operation or the reaming cycle, what we do. All these type of operations will be called under CAD cycle only. It is not like you're writing separate program for separate operation. You'll be having a main program and you will call for a sub program that will be nothing but the CAD cycle for different operation. It could be drilling, it could be threading, it could be reaming, it could be counter boring, yeah, finishing boring operation, whatever. So more than like 4 to 5 sequence of operations could be called and completed successfully within a main program. So this is the main advantage of using the CAD cycle within the main program. So you can call and compensate whenever it has been required. So apart from that, there is one more thing what you have to understand, it is a back boring cycle. It is not so regularly and oftenly used, but still as per the syntax, you should be knowing the back boring cycle. So here it is represented by the letter G87. So this will represent the back boring cycle. Okay, so the format for this is G87, and X and Y will provide the hole position, and Z will again provide you the depth of the hole, and R will provide you the initial safe position with which the tool is brought nearer to the blank. And then even in back boring, you need to have a lateral shift, right? So the lateral shift value will be provided by the value Q. And after the lateral shift, you need to provide some dwell time. So that dwell time will be given by the letter P. So you need to give what is a dwell time in terms of second here, and finally the feed rate. So this is the format what one follows for back boring cycle. So what happens basically in back boring? So first will be like you need to understand which are the motions which is coming into picture. Okay, so the first one is oriented spindle stop. So the spindle stops at a particular angle initially. Then what happens is a rapid sideways to the position that will enable the tool to enter the bore. So the spindle will get stopped, and then you will provide a safe rapid movement so that the tool will come nearer to the bore where the back boring operation has to be done. Okay, so this is the second movement. The first movement is the spindle will be stopped, it won't be rotating, and then you will provide a safer value, the rapid movement of the tool nearer to the blank where the boring operation has to be done. So it will show you the rapid movement. So after that, you should keep the tool in the rapid safe position before boring operation is done. So this will be the rapid safe position for the tool. Okay, so it will not be touching the blank, but it will be nearer to the blank. And then next motion will provide you the rapid sideways. So you have to provide a sideway for the lateral shift to be achieved with respect to the tool axis. First you will fix the tool here, then you will ascertain, and then you will provide what is called as the lateral shift distance which is needed with respect to the sideway. So you will be having again a rapid movement in this position. So the axis of the tool will be shifted here with respect to the bore axis. The bore axis will be here and the tool axis will be shifted over here. Once the tool axis is shifted here, then the spindle starts to rotate. Once the spindle starts to rotate, then you will provide the feed. Once the feed is given, right, so then it will go within the blank and do the boring operation. So once the boring operation is done, the spindle gets stopped, then you will provide a very safe value of the feed value, safer one, so that it will be removed freely above the blank. So once it is outside the blank, then you will remove the tool and keep it in the safe position. So it is little bit complicated operation which will be performed for back boring cycle. I hope we don't have any programs associated with back boring cycle, but still as per the syllabus you should be aware enough what do you mean by back boring process. So once all the operation is done, you have to return back to the main program, right? For that, you should use the code either G98 or G99. So G98, if you use, it goes back to the initial position where the tool was. And if you need, go back to exactly the position. Our position is a safe position. Suppose if you have the blank over here, right, the tool will be removed and kept somewhere nearer to the blank. It is in safe position. It will not be touching the tool. So if you need that position, then you have to write it as G99. If you want to move or send the tool back to its initial position away from the blank, then you have to type it as G98. So this will stop that particular cycle which was in operation. It could be of any CAN cycle operation what we have discussed until now. So these are all the type of CAN cycle operations what you have to be very clear enough before going into any type of milling operations. So after that we have a few G codes. what you have to be familiar with. So as usual, G00 stands for rapid traverse, G01 stands for linear interpolation, G02 for circular interpolation in clockwise. If you need in counterclockwise, it is G03. And for dwell time, we use G04. If you use G20, it is in inch. If you use G21, it is in metric unit. And if you want to send the tool automatic to zero return, we use G28. And if you want to return the tool for the second reference point, then we use G30. And if you need a single thread cutting operation, you have to type G32. If you need the tool compensation to be cancelled, then we use G40. If you need tool radius compensation towards the left, you will use G41. We have described all this. If we use G42, it is a tool compensation towards our right. Okay. And suppose if you need any work coordinate system, they say that we can use either from G54 to G59. Apart from that, the CAN cycle starts. So peg drilling cycle will be done by G73, finishing boring cycle by G76, the regular CAN cycle G80, drilling cycle by G81, counter boring by G82, deep drilling by G83, tapping by G84, reaming by G85, back boring by G87, absolute mode if you need, it is G90. If you need incremental coordinate system, you need G91. If you want to provide feed per minute, you have to go with G94 only. If you need feed per revolution, if you give feed once, that will be enough. So then it will be G95. And then if you want to return to its initial position in the CAN cycle, I told you right now, you will type it as G98. And if you want to go back to its position, then you have to go for G99. So these are the basic G codes, what we use often in case of CNC mill. Apart from that, we have the M codes. So if you want to stop the program, you will write M00. If you want to make the program, if you want to make in option the program stop, it could be a sub program or any other. So then you will go with M01. If you want to end the program totally, you want to write M02. And you know the spindle on M03 in clockwise. And if you need the spindle on in counterclockwise, you have to go with M04. And if you want to stop the spindle, we do write M05. And if you want tool change, you have to write M06. If you want to make the coolant on, you have to type M08. If you want to make the coolant off, M09. And this is the end of the program if you type M30. And if you want to call any sub-program, it will be M98 or M99. Sub-program call is for M98. And if you want to end that sub-program, you have to type it as M99. So from the next class, we will be starting with the milling operation programs, right? So today, I request you, everyone, those who have not completed, please write the record and keep it ready, right? So later, you just need to write an introduction to CNC mill and the syntax which has been followed and keep it ready for the next week. And from next week, we will be starting with the milling operations. So I will assign one more assignment post in the Google Classroom. For today's introduction class to CNC mill and the syntax, you have to write in your record and keep it ready. Hopefully from 17, the regular college starts. I hope you have received the information. We will meet in person and we can get your records evaluated.
No one will come to college, ma'am.
Why?
Parents are not allowing, ma'am.
Parents are not allowing. Why? What is the reason?
Ma'am, it's risky, ma'am.
Okay, all of you. Risky, I do agree, but now you have the examinations, so like UGC as well as the VTU suggests at least 1 month of in-person education that will help you people might to know exactly the things which are not much clear enough in online classes. So they have thought of this, and there is an option who are willing can come in person, and if it is difficult for someone to come in, then there is an option of online classes also. what the VTU people have suggested. So we need to check the number of students who are willing to attend in person and then online. So based on that, it will be like a two-way of teaching again. So that has to be rescheduled and everything get changed again. So we have to wait and watch what's the final decision which has been taken. Hopefully by today evening, we'll be having a clear-cut picture of what are the decisions taken. They say that from 17th it is offline. How many of you are willing to be on offline then? From my batch B1? No answer. Okay, you just speak with your parents. It is again the decision of your parents what they tell you. So now everyone, hope the concept of milling is clear enough. CNC mill.
Yes, ma'am.
Yeah, so now your work is to complete the pending programs what you people have not turned in yet related to the turning operations. Then start the record and complete that and submit me in the Google Classroom by next week. I'll post one more assignment in the Google Classroom for CNC mill. So you'll be having a 7 days of time again to submit that. But by today you see that you complete all the parts related to the turning operations. What all lagging pending work is there, you see that you complete it. Okay.
Okay, ma'am.
Yeah. So don't get delayed again. So or else the workload will be piled up at your end and my end also. See that it goes on smoothly so that at the end we won't be having any problem as such. So now I'll call the attendance. Abdul Khalik Pasha.
Yes, ma'am. Present, ma'am.
Yeah. Akhil KV.
Present, ma'am.
Yes, ma'am.
Yeah. Alok M. Alok M is absent again. I don't know why. Anil Kumar.
Present, ma'am.
Ankesh Aman. Ankesh. Ankesh is also absent. Gautam Krishna.
Yes, ma'am.
Balaji VR.
Yes, ma'am.
Okay. Basavraj. Basavraj
Yes,
is
ma'am.
there. Okay. Beldar
Yes,
Muhammad.
ma'am.
Yeah,
Yes,
yeah,
ma'am.
I listened you. Okay, both are present. Chaitanya.
Present, ma'am.
Chandan KN.
Present, ma'am.
Okay. Chetan Kumar.
Ma'am, Alok present.
Alok, where were you when I called?
My mic ain't working.
Okay, I have marked. See that your attendance is low. Don't miss any class. Chetan Kumar. Chetan Kumar is not there. Dheeraj. Dheeraj is absent. Ishant. He has messaged me, I saw.
I'm present, ma'am.
Yeah. Harshit. Harshit is absent again. Himanka.
Yes, ma'am.
Okay. Kanishka.
Yes, ma'am.
Yeah.
Ma'am,
Shri.
Harshit present.
Harshit, when I called you, why did you not answer then?
Ma'am, the call got cut, ma'am, so I had to rejoin
Okay,
again.
okay. Please attend regularly. You have missed 3 classes already. Himanka.
Ma'am, Himanka over, Kanishka also over, ma'am.
Over. Okay, I'm sorry. Kolepara Sri Naga. He is absent. Kunal Rajkiran.
Present, ma'am.
Yeah. Danush. Danush is absent. Mohammad Ayan. Mohammad Ayan is not there. Mohammad Junaid.
Ma'am, Mohammed, I am present, ma'am.
How many times should I call you? Okay, I marked your the attendance.
Ma'am,
Okay, I have marked. Mohammad Junaid is absent. Shri Prasad.
Present, ma'am.
Okay, so everyone, now it is 3:17. See that by 4:30 you complete the remaining pending programs of CNC turn and get the things cleared. so that in next week you'll be having only pending part related to the introduction of CNC mill. So from next week we will start doing 2 programs in a day so that we can wind up at the earliest related to CNC mill. So I just tell you again, see that by 4:30 I need all the programs which is in pending from your end. Don't delay anymore. Complete by 4:30. You have 1 hour still in hand. So see that you complete and turn it in quickly within 4:30. All the pending programs at your end. So everyone take care, be safe and have a nice day.
Ma'am, Himanka at present, ma'am.
Himanka, I called you. Where were you?
Ma'am, I said present, ma'am.
No, if you would have told
Yes,
present, I
ma'am.
would have marked
You called
attendance.
me 2 times, ma'am.
Ma'am, you called you called his name and then you called Harshit, no, ma'am.
I called his name, but he did not answer
No,
me.
by the
No.
time he answered, Harshit already answered, no, ma'am. So you got lost there.
Ma'am, I
Okay, so
already answered when you said at first
okay,
time. You called me again, ma'am.
okay, I have marked attendance. Himanka, right? ME020.
Yes, ma'am.
Yeah. Okay, then everyone take care. Complete the record and submit by 4:30 without fail.